Here's my second video on applications of quadratics, or in other words, quadratics word problems. And so in this first example, it says the length of each side of a square is 3 inches more than the length of each side of a smaller square. The sum of the areas of the squares is 185 square inches. What is the side length of each square? So let's start by, anytime I have like a geometry problem like this being described, I like to draw everything and label it. So let's say I've got a small square, and let's say I've got a slightly larger square. And so it is a square, so let's just kind of define the small square's side length as x. But then it says that the larger square has side lengths that are 3 inches more than the lengths of the smaller square. So if this smaller square had lengths of x, so that means this larger square had a length of x plus 3. And so basically we got to know how to find the area of a square, and so I'm going to kind of write the area inside in blue for each one of these. For their smaller square, it's length times width, so x times x would give us an area of x squared. And for this bigger one, it's going to be the same thing but with x plus 3 squared. And then we're kind of ready to set up our equation. Once I have this little visual of what's happening here, it tells us that the sum of the areas of the squares, is 185 square inches. So that means that the area of the smaller square plus the area of the larger square equals 185. And now I've just got us a little math problem that we can set up and solve. So we got our quadratic, so I'm just going to keep my x squared. In order to simplify this, I'm going to kind of come over here and maybe do some aside work. Maybe you can do that in your head, but for those of us that don't want that, I'll just kind of multiply it out. I'll do a box method. Maybe you like the box method, maybe you don't. X times x is x squared. X times 3 is 3x. X times 3 is 3x. And 3 times 3 is 9. Once I combine those like terms right there, that means that this part up here becomes x squared plus 6x plus 9. And that's still equal to 185. Now if we do some simplifying, x squared plus x squared is 2x squared. I still have my 6x, but then I need to make my quadratic equal to 0 before I can solve it. So I'm going to subtract 185 from each side. And when you do 9 minus 185, that's going to leave you with negative 176. And now we got our quadratic right where we want it. I'm going to kind of bring it over here where we have some more space to actually solve this equation. So 2x squared plus 6x minus 176 equals 0. So you can solve this using a number of methods. I think I'm going to go with quadratic formula on this one. We have our a value is 2, our b value for the quadratic formula is 6, and our c value is negative 176. So if we have x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And let's just take it step by step. I'm going to simplify it a little bit further in every step. 6 squared is 36. Whenever I multiply negative 4 times 2 times negative 176, you're going to get 1408. And then one more step would simplify that discriminant, which is the number inside the radical. Whenever I add those two numbers together, I'm going to get 1444. And this problem needs to end soon because we're running out of space. Negative 6 plus or minus the square root of 144 is just a regular 38. And now is where I kind of break this into two separate problems. I'm going to work it out once with the addition and once with the subtraction. With the addition, we do negative 6 plus 38, which would be 32 over 4, which gives us 8. That's one solution. For other solution, we do negative 6 minus 38. Negative 6 minus 38 is going to be negative 44 over 4, which is negative 11. Now, let's stop and let's interpret our answers. What we're looking for, keep in mind, is the side length of the smaller square. That's what we defined x as. While we have two different solutions that satisfy this equation, when we consider the context of the problem, we can't have a negative side length. So what I'm going to do is I'm going to throw that out as an extraneous solution. And we are going to use this. So therefore, if the short side, or the side of the short square is x equals 8, that would mean that the long side, or the side of the longer square, would be whatever x plus 3 is, which is 11. So 8 is this length, and 11 is this length. Let's look at another problem. In a right triangle, the longer leg is 7 units longer than the shorter leg. The hypotenuse is 9 units longer than the shorter leg. What is the length of all three sides? So what we got here is we got us a right triangle, so I'm going to draw us a right triangle. And it looks like we're defining both the long leg and the hypotenuse in terms of the shorter leg. So let's take our shorter leg and let's call it x. It says that the longer leg is 7 units longer than the short leg. That would mean this long leg must be x plus 7. If it's 7 units longer, that's x plus 7. It says the hypotenuse is 9 units longer than the shorter leg, so our hypotenuse could be x plus 9. And now our only question is, how do we actually set up our equation that we're solving in this problem? Well, hopefully you know that since they told you it's a right triangle, the relationship between the side lengths of a right triangle is that a squared plus b squared equals c squared. This is just our Pythagorean theorem. And now that I'm here, we're just going to solve this equation. I'm going to start by expanding out x plus 7 squared and x plus 9 squared. So let's do that first. So if I take x plus 7 squared, I'll just distribute over here. I'll kind of draw an arrow. So you see I'm coming aside and expanding that out. So x times x is x squared plus 7x plus 7x plus 49. Once I combine my like terms, we have x squared plus 14x plus 49. Let me bring that back in and copy down what we have. We have x squared plus 14x plus 49. For the sake of time in this video, I'm not going to do the same thing with this red binomial, but if you took x plus 9 times x plus 9 and came over to the side and multiplied it out, you should end up with the trinomial that is x squared plus 18x plus 81. Now, as we always do with quadratics, I'm going to collect all my terms to one side of the equation so that it equals 0. And so I'm going to start by, I'm kind of using all my colors here. I guess I haven't used green yet. I'm going to subtract x squared from each side. I'm going to subtract 18x from each side. And then I'm going to subtract 81 from each side. And so in doing that, we have x squared minus 4x. I get that by doing 14x minus 18x. And then lastly, our constant 49 minus 81 is going to give us a negative 32, and that equals 0. And so now we've gotten our quadratic down to a pretty simple standard form here. And you could solve using quadratic formula or whatever method you like. Since I haven't really done it, we're going to solve this by factoring. Factors of 32, or negative 32, that add up to negative 4. It's going to be x minus 8 and x plus 4. From here we can use zero product property. If this times this is 0, that means the only way to have that would be if either this factor was 0 or if this factor was 0. So if I solve this factor and get that x is 8, I could solve this factor and get that x is negative 4. Now, let's interpret our answer. That's important here. Keep in mind, we are talking about, we defined x as the length of the shorter leg. And so if x is negative 4, that would mean that we have a negative distance or a negative length, and that doesn't make sense in terms of this problem. Although it's a valid solution to this equation, given the context of the problem, we're going to throw it out as an extraneous solution. So what that means here is that means that for our triangle, we have one side length, our short side is x, or excuse me, is 8. Our longer leg, 8 plus 7 would be 15. And then our long leg, x plus 9, would be 17. And those are the lengths of our right triangle.